Hello guys, in this video I'm going to show you the simplest and fastest way to do electron configuration. So as we have learned before, electrons, they occupy energy levels, and these can be represented with the number of L1, 2, 3, 4 and so on. So energy levels, they have sublevels, or we also call it as subshells, and this is represented by the sublevel of S, P, D, F, and we have more. And in sublevels, we have orbitals. So for each of these sublevels, for S, it has one orbital. For P, it has 3, D, it has 5, and for F, it has 7. And each of these orbitals, they can hold up to 2 electrons. For this one, up to 6 electrons. For this, up to 10 electrons. And for this one, up to 14 electrons. Okay, so for electron configuration, this is actually a summary of where the electrons are found around a nucleus. So this is your nucleus, and this is where your electron circulates. It can be found. The probability of finding an electron around a nucleus. So this electron configuration, it kind of places the electrons into a certain arrangement around the nucleus, which indicates their energy levels and the shape of their orbitals in which they are located. Okay, let's check out one example here. Let's say we have here nitrogen. So nitrogen, the number of electron is 7. So let's check out how are we going to place these 7 electrons into the levels, sublevels, and the orbitals. The order in which the electrons are placed into the orbitals, which is the S, the P, the D, and the F, is based on the order of their energy. So this is referred to the Aufbau principle. And the lowest energy orbitals will be filled up first. So we have here, this is being used by, many. This is like a common way to do electron configuration by drawing up a diagram that helps us to identify the location for all the electrons. So we have here, we have here 1s, energy level 1, sublevel S, and then we have 2s and 2p. The energy level 2, we have 2 sublevels. Energy level 3, we have 3 sublevels, and energy level 4, we have 4 sublevels. So I'm not going to go further than this. We have more actually, and we have more sublevels, but I think we're going to stick until the 4th energy level and the F sublevel. All right. So we're not going to need more than that. So I'm going to draw up and down arrows on the horizontal line to indicate that an electron in an orbital is filled. So let's look at this nitrogen here. It has 7 electrons. So as we know, for the S subshell, it can hold up to 2 electrons. For the P subshells, it can hold up to 6 electrons. For the D, up to 10 electrons. And for the F, 14 electrons. Okay? So this is 7. So let's draw a horizontal line like this, or an arrow. It means that 2 electrons have been occupied by one S. So 2 electrons here. So we're gonna with it. So that leaves us with 7 minus 2. So it leaves us with 5 remaining electrons. So let's draw another arrow here. So 2 more electrons have been filled up, minus 2. So that leaves us with 3 electrons. All right. So we have to draw like this. The configuration is 1s2, 2s2, and this one first, 2p3, although it can hold up to 6 electrons, but we only have the remaining 3. So that's why 2p3. So this is the configuration for nitrogen. Alright guys, let's try another one, sodium, with a total number of electrons of 11. Okay, so let's check out its electron configuration. Alright, again draw the diagram. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. Alright, and then actually we have another one for F here. Okay, so 11. So here 11 minus 2, we have 9, minus 2, we have 7. So this one can occupy up to 6, minus 6, we have 1. And this one can fill up, it can fill up the 3s. So the configuration is 1s2, 2s2, 2p6, and 3s1. So this is the configuration for sodium. How about another one? Let's try for chlorine. Okay, chlorine. Chlorine, in which the atomic number is 17. So this is also the number of electrons. It has 17 electrons. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Okay, so we have 1s2, 2s2. So here definitely 2p6 and 3s2. So we already have 6 plus 2 plus 2 plus 12. So remaining 5 electrons. So the next one is this one. Okay, so 3p, since we have 5 remaining electrons and this can fill up to 6 electrons, so we only have 3p5. So this is the electron configuration for Cl. Okay guys, hope it helps. Thank you.